I'm Anil Kumar sharing with you set of questions from previous test papers on probability. We'll be using counting techniques to answer most of these questions. There are 12 questions in this particular video to be answered. I would like you to first copy them, try them out, and then look into my suggestions. As you can see, the first three are communication-based questions. We'll talk about probability as a likelihood in the first question. We'll try to explain the difference between trial, outcome, and event in a probability experiment. And then you need to describe different types of probability which have been taught to you. Question 4 onwards, we have knowledge-based questions. You need to find probability for different kinds of events. So I'd like you to take your time, copy these questions. I'll take them one by one, right? So these are 5 questions and now 3 more. So I hope you can see all 8 of them. Copy these questions and then, on the next page we have 4 questions. Question number 9 to 12, which I have placed under thinking heading. I hope you find them interesting and useful. Now let us take these questions one by one and see how they can be answered. The very first question here is, fully explain what each of the following probability values implies about likelihood of an event A occurring. Do not use any numerical terminology, right? So when we talk about likelihood of a probability of an event happening, that is what basically the probability is, right? So probability of an event is qualified measure. You can always say probability of an event is a qualified measure of the likelihood that the event will occur. Correct? So probability of any event is actually between 0 and 1. So here we have probability of an event A as 1. It means that the event is certain, 100%, right? So 1 means certain. Or you can say 100%, right? That is what it means. Probability of 0 means impossible. And what we have here as 0.5, let me write separately. So probability of an event equals to 0.5 means equally likely. Right? So that is what it is. Now if you take up an example, let us say that you toss 2 coins. Right? So in that case, the probability of which is impossible will be to get 3 tails. Right? You're tossing 2 coins, you could get either 2 tails or 3 tails. You cannot get 3 tails, for example, right? So, and it is certain that it will be combination of 2 tails, 2 heads, or tail and head, right? So it will be combination of these. If I say the probability of having 2 tails or 2 heads, these are equally likely events, correct? So that is how you can understand what likelihood is, right, of an event happening. Certain probability of sun rising from the east, it is certain, right? So those are the kind of events which will be treated as 100% probability, right? So you're 100% sure is going to happen, right? Okay, so let's move on. to question number 2. Question number 2 is, explain the difference between a trial, an outcome, and an event in a probability experiment. Right? So basically, we should understand that whenever we are doing an experiment, in that case, probability of an experiment is always well defined, right? So what is important to understand here is that in any experiment, a couple of things are important. That is, we have more than one output. Second, that none of the outcomes is sure. Right. So there is likelihood. That means there is always likelihood of an outcome. Is it okay? So that is the probability experiment. So whenever you conduct an experiment, then what is a trial? Trial is a step in the probability experiment in which outcome is produced, right? So let me write down here, trial is a step in probability experiment in which an outcome, you can say result, is produced. It is not only produced, it is also recorded, right? So it is also recorded. Right? So that is the trial. For example, if you just throw a dice, then any number between 1 to 6 can come. So every throw is a trial, right? So in a dice, each roll or throw is a trial, correct? Now, so whenever you do a trial, there will be an outcome. So outcome basically is the result of a trial, right? So in case of a dice, the result could be any number between 1 to 6. Correct. And set of outcomes is an event, right? So that is how they are all related. So I hope these points are absolutely clear. Now I'll recommend that you should read from your book the exact definition and then understand it better, right? So I'm just giving you an idea here. Question number 3. Discuss the 3 types of probabilities introduced and discussed, right? So in different classes that will be different. However, most of the students who are studying here, they look into 3 types of probabilities. One we call as empirical probability. Also experimental. The second one is theoretical. And the third one is subjective. Right? So these are the 3 types of probabilities which we have discussed at length, right? Now, empirical probability or the experimental probability is based on direct observation. So it is based on of experiment conducted, right? So you should actually conduct the experiment many number of times to get better results. That is kind of important, right? In theoretical probability, that is based on mathematical analysis. And the subjective probability is based on informed guesswork. Or you can say prior knowledge. Right? So these are the three types of probabilities which we have done. For example, you can say empirical probability is you can play with a rolling die is 100 times and then find the probability of getting 6, for example. Theoretical probability will be 1 out of 6, right? And subjective property is like, is it likely to rain tomorrow? Those are the questions which will be answered, right? So we'll take a few questions on subjective probability as a part of this question set also. So I hope that helps. Now, question number 4 here is, what is the probability of drawing each of the following from the standard deck of cards? A red card, a non-face card, a 6 or a 5. So now we are moving into knowledge-based questions where we are going to answer most of the question using theoretical probability. So to find probability, we have to look into total number of trials over favorable trials, right? That is what probability is. Now, probability for getting a red card is how much? Since there are 52 cards in a deck of standard cards, so 52 comes in the denominator, that is the total sample space. And favorable are the red cards, which are 26 in number, right? So the probability is half, or you could write 50%. Correct? Question number 2, a non-face card. Now, what are the face cards? Jack, Queen, and King are the face cards, right? And these are 4 types, correct? You could also consider one set of 13 in which 3 are face cards and the rest 10 are non-face cards, correct? So you would write this probability as, let me write like this, non-face card, right? As, since there are 3 out of 13 as face cards, we could straight away write 10 are not face cards out of 13. That makes sense, right? Or if you're looking from a pack of 52, right? So 10 times 4, so that is 40, right? 10 times 4. Since in every set of 13, 12, 4 times 3, 12 are face cards, right? So sorry, 52. 52, right? So 40 over 52 could be the other choice, right? How do we get 40? Well, some of you could see it like this, that out of 52, 12, 3 times 4 are face cards, right? Rest are not face cards. So, and then 52 in the denominator. So these are different ways of approaching the particular question, which simplifies to 10 over 13, correct? The last option here is part C, a 6 or a 5. So in a pack of cards, there are 52 cards in all, so that comes in the denominator. 6 or 5. That means we have, or means we have to add. There are 4 6 and 4 5. So 4 plus 4. Right? So we get the result as 8 over 52. Right? So that is how we could answer this. Right? Dividing by 4, we get 2 over 13 as our answer. So that is how you could answer this. So I hope the steps are clear. Now, I'm not really describing probability since it's a part of test. I'm trying to give you hints to solve these questions and get the answer. Question number 5. Now this is based on subjective probability. Estimate subjective probabilities for each of the following events and provide justification. That is important, right? So it will snow tomorrow. So it really depends on the season you are working, right? So this season is past winter. We are approaching summer. So less likely could be the answer, right? So the answer is less likely. So when you answer based on subjective probabilities, we are given terms in terms of impossible, certain, likely, equally likely, and those are the types of answers providing with season, right? Less likely since we are approaching summer, right? Winter is over for us now, right? So at this time, it is less likely. The next question here is, the next person to enter the school will be a teacher. Well, that is even lesser likely since there are more students, there are much more students. In a school than teachers, right? So it is also less likely. You will get married, most get married, right? So it is most likely. Since most get married. So if you provide a good reason for it, it's okay. It's a subjective probability. It's what you think, right? Based on the knowledge which you have, correct? So let's move on and now answer question number 6. Question number 6. What is the probability of not rolling a composite number with a standard pair of die? Let's be clear. With a standard pair, we're just talking about one die, okay? With a standard die, let's say that, okay? So if I have a die, that is, what are the numbers you can get? Well, you could get numbers like, so we have numbers like 1, 2, 3, 4, 5 or 6. So that is the sample space, right? So we have the sample space, we have 6 numbers. Now what is the probability of not rolling a composite number? So out of which, what are the composite numbers? Well, the composite numbers are 4 and 6, correct? So these are the only 2 composite numbers, and therefore probability of not composite numbers is clearly 1, 2, 3, 4, right? Is 4 out of 6 or 2 out of 3. Okay, so that is how it could be answered. Question number 7. 2 standard dice are rolled. What is the probability that a sum of more than 7 will be rolled? So in this case, it is better to make a matrix, right? So let's make a matrix here, and then it'll be easier for us to solve, right? So So with each die, we could get numbers 1 to 6. So 1, 2, 3, 4, 5, 6. And this way also 1, 2, 3, 4, 5, 6. Correct? We are looking for sum, right? So the numbers could be like 1, 2, 3, 4, 5, 6. Or with the other die also 1, 2, 3, 4, 5 and 6. We add them. So if you add them, what do you get? 1 plus 1 is 2. And when you add, you get 2, 3, 4, 5, 6 and 7. And when you add these, so you'll get 2 plus 2, 4, 5, 6, 7. Okay. So I just made it wrong. 2 plus 1 is 3, 4, 5, 6, 7, 8. When you add 3, 4, 5, 6, 7, 8, 9. When you add 4, 5, 6, 7, 8, 9, 10. With 5 we get 6, 7, 8, 9, 10, 11. And we get 7, 8, 9, 10, 11, 12. More than 7 means we are looking for a set which is right here. Correct? So how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So the probability for greater than 7 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 6 times 6, which is 36. Right? So that is the matrix. So that is your answer, correct? You would always divide this by 3 and simplify this to 5 over 12. So that becomes the answer, right? Okay. Next question here is, a number is chosen from the first 30 natural numbers. If the event A is multiple of 4, then what is probability of not A, right? Complement A. So we have numbers from 1 to 30. That is what we have. Now out of these, what are multiples of 4? So less than 30, we have 7 multiples, right? 7 times 4 is 28. So you could write numbers like 4 and then like 8, 12, 16, 20, 24 and 28, right? So 1, 2, 3, 4, 5, 6, 7 to be precise. And since total numbers are 30, we want not A, right? So either way, you could do probability of not A will be equals to 1 minus probability of A. So which is 1 minus. Probability of A is 7 out of 30. So that could be one way of doing it. You could directly also find not A by taking away these numbers from 30, which is one and the same thing. So you definitely get the same answer, which is 30 minus 7 over 30, correct? Which is 10 take away 7 is 3. So we have 23 over 30 as our answer. So I hope that is clear, right? Now we are into some thinking questions. Question number 9. A couple plans to have 4 children. What is the probability that the couple will have 3 girls, 2 boys, at least 1 boy? I'd like you to pause the video, answer this question, and then look into my suggestions. Now we are into thinking section. Well, to answer this, there are many different approaches. When we have a couple which plans to have 4 children, what you could do also is make a tree diagram, right? So we can say girl or a boy, and then again girl or a boy, girl or a boy, and then continue, right? So this could continue 4 times, correct? So that is one approach. Definitely you'll get right answer, but that is going to take a lot of time. So my suggestion is that in case it is specified then make a tree diagram and then do it, then you know you have no option. Go for that. Perfect. And then get your answer. Now I'll use a different approach to find the answer. So in this particular case, we have a couple which plans to have 4 children, right? So it is kind of like this. So a girl and a boy, then again, if you have a girl, you may have a girl or a boy, then again a girl and a boy, right? So we could get girl and a boy, and then could be again like girl and a boy, right? And this thing kind of continues. So there are 4 levels to which it could be drawn. Perfect. So in this case, in our sample space, we can write how many are total number of combinations. So since we have only 2 options, we have 2 to the power of 4, which is 16. Correct? So that comes in the denominator. Now we need probability for 3 girls. So if that is the event A, in that case, how many are the cases out of those 16 which will give us 3 girls? That is what you have to think about. Now a good approach here will be that there are 4 cases, right? So basically what we are looking for is 4 positions, right? 1, 2, 3, 4. Now when I say 3 girls, so 3 girls means a boy, right? So 3 girls means 1 boy. Perfect. So just exactly 3 girls. So what you could think about is boy could be in position 1, first boy, second boy, third boy, or fourth boy. Do you see that? So there are only 4 cases. There are only 4 cases of having 3 girls. You could have a boy and 3 girls. You can have a girl, boy, and then 2 girls. 2 girls, boy, and then a girl, or 3 girls and a boy. So these are the 4 cases, and therefore the probability of our event A, let's call this as event A, is equal to 4 over 16 or 1/4. Does it make sense to you, right? So if you go with this strategy, you're really going to save a lot of time, right? So that is how you should be doing it. Now let's look into part B, and let me call this as our event B, right? So event B is 2 boys. So again, we'll try to figure out some way to find how many are favorable chances of having 2 boys. Exactly 2 boys it means. Is it okay? It is not saying at least. There is a question here which says at least 1 boy. But this one is exactly 2 boys. So 2 boys means exactly. Do you understand? Exactly 2 boys. Now, what are the different ways of having 2 boys? Now think like this. If first one is a boy, correct? If first one is a boy, then the second boy could be here, there, or there. So we have 3 combinations. Do you see that? Correct? So we have 3 combinations. Now let's go for one more type, which is if the second one is a boy, not the first one, in that case, the boy could be either here or there, right? So either here or there, right? So one of these 2 combinations. Is it okay? So if second one is a boy, not the first one, in that case, we have boy-boy combination, or we have boy-girl, boy combination, girl here, right? So that gives us 2 combinations. Now think about boy being born in the 3rd position. So if the boy is born in the 3rd position, then we have 1 combination, correct? So that is only 1 combination. So total number of ways is 3 plus 2 plus 1, which is 6. So therefore, for 2 boys, we get 6 out of 16 as our answer, and dividing by 2, we can divide by 2, so we get 3 over 8 as the probability of event B. Correct? So that is how you could answer this question. Now, Let's look into the third question, which is at least one boy, right? So at least one boy means not all girls. That means not all girls. That is what it means, right? Now, so the probability, let me call this as C, right? C at least. So what we will say here is C prime is all girls. So that is the event. So of all girls, and for this we have only one combination, right? So the probability for C will actually be out of 16, only one is for all girls. So rest 15 will give us at least one boy. Does make sense to you? And therefore this probability is 15 over 16, correct? So that is how we could actually answer this question in no time without making a tree diagram, right? So suggestion is that if tree diagram is not asked for, don't go for it, right? Now let's move on to question number 10. Question number 10. What is the probability that at least 2 people in a class of 28 students have the same birthday? Assume that no one in the class is born on 29th of February. That means we are selecting 365 days from a year, right? So 365 days a year. Now, when we want to find probability that at least 2 people in a class have same birthday, what we can do is that we can find complement probability, right? So we can have probability for at least 2 have same birthday. It also means we could do 1 minus probability for no one having same date, same birthday, right? So that is how we can actually do it. So when I say no one having same birthday, that means all are born on different dates, right? So this means all are born on different dates. Okay? If not, then we'll meet our condition, which is at least 2 people were born on the same date. So I hope the concept is clear, right? Now, we could write this probability as 1 minus. Now there are 28 students, right? So there are 28 students. So for the first student, we have a choice that the first student could be born on any of the 365 days. So that is the choice, and total number of days available are 365. For the second student, again, we have 365 days in a year, but since one has been occupied, we are left with 364 days, right? For the third, it is one less, 363 days over 365, okay? So like this, the series will continue. And for the 28th person, it should be what? 365 in the denominator. And here, see, for the second, it was one less. So here it is 365 minus 27. Is it okay? So that becomes the number of choices for number of days left for the 28th person, right? So that becomes the probability. Now we could write this as 1 minus. Now let me rewrite this as 365 times 364 times 363 times up to, so this is how much? Let's use the calculator. We have 365 minus 27. The last number is 338. Now that is a huge number, right? And the denominator here will be 365 to the power of 28, as for 28 persons we'll have these fractions, 28 of them. Right. Now to calculate, we could see this number as 1 minus 365 factorial divided by 337 factorial, right? 337 factorial over 365 to the power of 28. Do you see that? So that gives you the answer for the given question. Now you need to have a good scientific calculator to calculate this out. So I'll leave this for you. You can actually calculate this answer and write it down. And we'll continue with the next question now. Question number 11. Peter just wrote a multiple choice test with 15 questions, each having 4 choices. He showed that he got exactly 9 of the first 12 questions correct, but he guessed randomly on the last 3 questions. What is the probability that he will get at least 80% on the test? Now, what we are going to assume here is that in the first 12 questions, he shows that he has got exactly 9 correct. That means 3 are wrong. Correct? Now, but he guessed randomly on the last 3. So in the last 3 is basically random guess. That is the question, right? Now, how can he get 80% marks? To get 80% out of 15 questions, that means 15 times 0.8, we get what? So 8 times 5 is 40 and 1 is 12. So it is 12.0. So we want 12 correct answers. So we already are sure about 9. So that means these 3 should be correct. So that means 3 should also be correct. Correct. Now since we have 4 choices in each, so for these last 3 to be correct, the probability will be what? So probability for 80% in this scenario is when all the 3 are correct. And there is only one correct answer out of 4. So it is 1 out of 4 times 1 out of 4 times 1 out of 4, right? Which is 1 out of 4 times 4, 16 times 4, 64. So that becomes the answer for the given question, right? So I hope the concept is clear. Now, if all the 3 are correct, then we are sure he gets at least 80%. Now, he's sure about 9 correct answers, 3 wrong. They might be right, right? So that means there's a possibility of Peter getting more than 80%. But this has to be ensured to get at least 80% correct. So I hope the concept is clear. And since we have a multiple choice questions with each having 4 choices, 1 out of 4 is probability for getting those correct. 3 in a row means 1 out of 4 times 1 out of 4 times 1 out of 4, which is 1 over 64. Okay? Question number 12. This is the last question of our test series on probability introduction. Question number 12 is, Anil lives 4 blocks south and 4 blocks east of Bill. They both leave their house and walk towards each other at the same time with the same speed, taking no particular route. What is the probability that they will meet? So let's sketch the diagram. So let's say we are given these positions. 4 blocks south, 1, 2, 3 and 1, 4. 4 blocks east, 1, 2, 3 and 4. Let us say Anil stays here, Bill is in that position. since Anil lives 4 blocks south and 4 blocks east of Bill. Now, we'll utilize the knowledge of paths which we have learned using Pascal's triangle. So if Bill takes the path east, there is only one way going east, one way going south, correct? Now, to reach this spot, we have to add the previous two. So there are two paths. Here 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. To reach this spot, it will be 1 plus 2 is 3, 3 plus 3 as 6, 6 plus 4 as 10, 10 plus 5 as 15. Now it is kind of important to understand that if they are meeting, they are going to meet right at the center since they are walking with the same speeds, right? So walking with same speed, correct? That means they can only meet after covering 4 blocks. In total, there are 8 blocks to be covered, right? 1, 2, 3, 4, 5, 6, 7, 8. So in between, if they have to meet, so they will meet when they cover 4 blocks each, right? 4 for Anil, 4 for Bill. Or it could be this side, 4 for Bill, 4 for Anil. Or it could be 1, 2, 3, 4, something like this, right? So these are the probable point of intersection, if at all they are meeting. Is that clear, right? So we will concentrate on these points. How many routes are there to reach these points? That is the strategy, right? So the red marks here indicate the possible meeting points. So we'll actually find the number of paths leading to these possible meeting points. 1 plus 3 will be 4. Here we have already found 6, 6 and 1, right? So let me circle these possible meeting points for both. Now from the symmetry, you can say that for Anil also, same numbers will come, right? So if I add from this side, we are going to get the same numbers as 1, 4, 6, 4 and 1, right? So how many possible paths could lead to these junctions, right? So total possible paths total possible paths will be 1 plus 4 plus 6 plus 4 plus 1, right? Will be 1 plus 4 plus 6 plus 4 plus 1, and that is 5 and 6, 11. 11 plus 4, 15 and 1, 16. So these are total number of paths which Ben could take. And even if I start from Anil's side, from the symmetry, it will be same number of paths, right? So these number of paths are total 16 for us. Now, probability that Bill will take this path and Anil will take this path is what? Is 1 out of 16. Do you see that? So probability of meeting, let's say probability of our event A is meeting at this point. They could meet at this point, or they could meet here or there, or. So there are or operations. But at this point, it is 1 out of 16 for Anil and Ben. So it is 1 out of 16 times 1 out of 16 plus. For the second path, there are 4 ways of going through this, right? And 4 ways for Anil, right? So that is 4 out of 16 times 4 out of 16 plus. For this path also, we have 6 ways in which Bill can reach and 6 ways when Anil can reach. So I could write this in short as 6 over 16 whole square, right? When you multiply, you get that. And in here, we have 4 over 16 whole square plus 1 over 16 whole square, correct? So that becomes the probability. So I could write this as 1 square plus 4 square plus 6 square plus 4 square plus 1 square. That's the numerator. Common denominator is 16 square. So we can use a calculator to figure this out. So it is 1 square plus 4 square plus 6 square plus 4 square plus 1 square, which is equal to 70 divided by 16 square, which is equals to 35 over 128, right? So that becomes the probability of their meeting somewhere in between, as shown in this particular diagram. So I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. All the best for your test. Thank you.